Okay, in this lecture we're going to talk about plotting the graph of a quadratic function using what's called the vertex form. You'll recall that we can write a quadratic function in this form where, of course, the h and the k is what's called the vertex. Alright, and also, of course, this number in here, if it's positive or negative, then it opens upwards. If it's positive, if it's negative, then it opens downwards. So that also tells us the orientation. And so this form is quite good for graphing the quadratic, as long as we can find h and k. Now, of course, if we have it in general form, we can use completing the square to actually get it into this squared form. Now, once we get it into the squared form, we know that we can determine the vertex, and we also know that we have some symmetry about the line that goes through the vertex, x equals h. Right, so we're going to use these facts to actually plot the quadratic in a much more easier way. Now, what we need to do here is complete the square. Now, you remember that completing the square requires there to be a 1 in front of the x squared. So the first thing we need to do is take out a factor of 2, and I'll get an x squared minus a 2x. I'm going to leave some space there and leave the 5 outside the parentheses. This is the part I'm going to complete the square on. Now, you remember that completing the square means I need to halve the negative 2 and then square it. Now, half of negative 2, of course, is negative 1 squared, is plus 1, but I must also subtract a 1. I just can't add 1, all right, and change the problem. So, however, what I need is to complete the square on this. So I'm going to move that negative 1 out of the parentheses by distributing it, the 2 onto the negative 1 to give me a negative 2 plus 5. Right, make sure you're clear on that. We're distributing that 2 into the negative 1 to get it outside the parentheses. We know that this part here is the perfect square part, and of course we have a plus 3. Now, if we now match this up with our ax plus minus h, I should say, squared plus k, we can see that our vertex is going to be 1, because there's a negative here, so you match it up, and a 3. So there's our vertex, and we know that there's going to be an axis, right, that goes through the point, the x value of the point, so that's going to be 1. Right, so we can now plot 1, 3, and here is my vertex. I can see that a here is equal to 2, which is positive, so I know it's going to open upwards. So I've got to go upwards, and so now what I do is I say, well, what happens if I have x is equal to 0, for example? Well, if x is equal to 0, we end up with 5, so f of 0 is actually equal to 5. So I end up with the point 0.5. Now remember, our axis of symmetry goes down through here, and so I know that this is also a point. Right, now what happens if I now look at, say, x is equal to 3? Well, what's f of 3? Well, f of 3 is going to be 2 by 9 minus 12, 4 by 3, plus 5. So this is going to be 18, and 5 is 23, minus 12 is going to be 11. So I need 11, which is a little bit off my thing here. So this is 9, 10, 11. So we go here, and so we end up over here as well. Let's get that out of the way. So, so it's going to be about here. Right, so that means that our curve is coming down like this, around and back up, like so. And that's going to be our curve. Notice that the axis here is x is equal to 1. The vertex here is going to be 1, 3. Notice that we have a minimum at x equals 1 of 3. Okay, so notice that we have the domain, of course, is negative infinity to infinity, and the range, of course, is going to be from 1 to infinity. Now, you can see here that we could draw this quite a lot easier than plotting a whole bunch of points by identifying A, seeing which way it opens, up or down, finding the vertex and therefore an axis of symmetry, and then plot a couple of points, and we can just use symmetry to plot two other points, and then we can draw the curve. Right, so that leads us to wanting to know, can we do this to every function? And can we do it in an easier way? All right, because remember, if we have a number in front of the x squared, we've got to take that out first. What happens if I don't have a nice factor here? I'm going to get fractions, and it's going to be unpleasant to work with. So I want you to think back on how we showed we could get the quadratic formula from a general quadratic equation. Now, we don't have a quadratic equation, but we have a function in general form for a quadratic, which is like this. Now, if I was to complete the square and follow this process up here, I'd take out an a, and I have an x squared plus a b over a, x. All right, I'm going to leave a bit of room and leave the add the c here and see what happens. Now, to complete the square here, of course, we'd have to halve the b on 2a and square it. Now, that would be, of course, b on 2a squared would be b squared on 4a squared, and we'd have to subtract b squared over 4a squared. Now, like we did up here, I want to get this part out of the parentheses. So this will be a by x squared plus b on 2a plus b squared on 4a squared. Now, when I distribute the a through here, I'm going to get a negative b on b squared on 4a, because one of the a's cancel, plus c. Now, you'll notice that if I match so I now complete the square on this, the perfect square would in fact be x plus b on 2a, all right, plus c minus b squared on 4a if I put the positive one first. Now, if I match that up with a by x minus h squared plus k, you can see here that our h here, because of the negative, would in fact be negative b on 2a. Our k would in fact be c minus b squared over 4a. But more importantly, of course, f of h, which of course is f of this negative b on 2a, is going to be equal to the k value. Okay? Alright, because if I put that in there, that goes to 0, and of course I'm just left with this part here. Now, the point being, of course, is that we now have a way that we can always find the vertex. Right, it's going to be found, the x value is going to be found by negative b on 2a, and then the k value can be found by just evaluating the function at that value. Now, that's going to make things a lot easier, right, because all we have to do is identify a, b in our general quadratic formula, and we have our x value, and then we can find our y value. Right, so let's do that. So in this case here, we have a is equal to negative 3 and b is equal to 12. So my x value for the vertex is going to be negative b on 2a, which is going to be negative 12 over 2 by negative 3, which is negative 12 over negative 6, which of course is 2. Then if I look at f of 2, this is going to be negative 3 by 2 squared plus 12 by 2 subtract 8. So this is going to be negative 12 here plus 24 subtract 8. And this is going to be, that'll be 12, so that'll be negative 4. So my vertex is going to be 2, negative 4. And my axis is going to be x is equal to 2. And I think that actually is, so it's actually plus 4. Alright, so it's going to be 2, 4. So that allows me then, and of course what's A? A is equal to, we just looked at it here, negative 3, which is less than 0, so it's going to open downwards. Alright. Right, so let's put in our vertex, 2, 4. We know our axis, alright, is going to be x is equal to 2. Alright, so here's 2, 4. Okay, now we know it's opening down, so the next thing to do is what is going to happen when x is equal to 0. Then, of course, f of 0, we can see here, 0 here, 0 here, so it's negative 8. So it's going to be 0, negative 8, which is right here. So I'm going to follow my axis down, and of course, right opposite there is going to be the other point. Now if I put 1 in there, what happens if I get 1? Well, it's negative 3, and this will be negative 8, will be negative 11, plus 12 would be 1, so I end up with it. This is another point here, so here's another point here, and so now we can draw our function like so. Alright, so here's our vertex, which is 2, 4. Here's our axis. Right, notice that we have a maximum of 4 at x equals 2. Right, our domain, okay, of course, is negative infinity to infinity. And our range, of course, is now negative infinity up to 4, including 4, and there it is. And so we can see it's quite easy to draw this function once we have that particular vertex. And the vertex comes just by knowing what a and b are. It's negative b on 2a, and then finding what the y value is by finding the value at this negative b on 2a. That gives us the vertex. We know the axis. The A will tell us whether it opens up or down, and then we can plot a couple of points and use symmetry to actually finish the graph. And you can see that this is a much easier way of doing it than going through the whole completing the square issue, which can often lead to some rather nasty fractions that we have to deal with.